One of the first aspects to make note of is the morphology, or the shape of the particles. Crystalline materials tend to form as one of a few commonly observed shapes, described with very generalized terms, focusing on the ratio of their dimensions. A block-type crystal has a relatively even ratio of sizes across all three dimensions. These are usually the most favorable and the easiest particles to work with. Plate-type crystals grow rapidly in two directions and slowly in one, resulting in thin, flat formations. These crystals tend to stack onto each other very readily and can frequently end up layering in such a way as to resemble a block. If a crystal grows rapidly in one direction, then the crystal is either a rod or a needle, depending upon how thick it is in the smallest dimension. Rod-type crystals are frequently going to be seen as having a hexagonal cross-section, but if it's too thin to identify the shape of the cross-section, it is definitely a needle. This is a bit of a simplification, as the shape of a crystal, called its habit, has much more detailed categories with a lot more information that can be inferred by an expert, but that'll be discussed in the crystallography section later on. Needle-type crystals, in particular, can sometimes demonstrate a few additional complications that need to be worked around, such as the tendency to form into bundles. This can complicate characterization in the solid state and can often mean that the solids are less cooperative as powders with regards to handling and transferring. Additionally, the examination under PLM can give good information with regards to the formation of agglomerates, where particles are fused together, or aggregates, where particles have loosely drifted together. Agglomeration is determined by the conditions of crystal growth, and changes to the crystallization process may avoid them. Aggregation is a function of a solvent that doesn't wet to the particles, but can be broken up with brief sonication or agitation introduced through another method. Aggregation and agglomeration can present major obstacles in processing an API. These will be more important when evaluating the particle size distribution, which we will discuss shortly.